Hello, welcome everybody to this session about Paketo Buildpacks. Are they the best way to build Java container images? I am Anthony Dahanne and I am a software developer. I'm working for Broadcom inside the Tenzu division that is in charge of maintaining the Buildpacks. And more particularly, I am in the Java Buildpacks team along with David. Hello, David.
Hello.
Okay, so without further ado, let's get us started with today's presentation. Of course, we are going to talk about Buildpacks, and first we're going to define them. Then there's a very frequent questions about Buildpacks. Is it worth it? Are they worth it compared to Dockerfile? Are you supposed to migrate away from Dockerfiles? And then we'll see how and where you can use the Buildpacks. Okay, so what are Buildpacks, David?
Okay, so Buildpacks at a high level take your source code and turn them into container images that are ready to run your app. Buildpack itself is essentially a set of two binaries, one called detect and one called build. The detect binary basically determines whether the Buildpack should proceed in the build stage. So for example, the detect binary for the Maven Buildpack will, among other things, check for the presence of a pom.xml, and that will mean that Maven will be used to build this app in the build stage. The detect binary for the executable jar, as another example, will determine whether a jar is going to be the output of your build, and if so, it'll set the start command to java-jar on your app, as you can see on the top here. So the build binary then, this is the binary that does the chunk of work to actually build your app. It performs a number of steps like setting environment variables, downloading dependencies, and contributing the layers for the container image. So we can see some sample output here from the build binary phase. The first one is the JVM vendor Buildpack. This will install a JDK, a JRE, and the native image toolkit if you're doing native builds. In the case of a Maven app, this will install a JDK just for the build to do the actual compilation, and then the JRE will end up in the final runtime image. The next one then is the Maven Buildpack that I mentioned. This will check for Maven on the path or look for a Maven wrapper script. If Maven isn't found, it'll install it for you. Okay, so where do Buildpacks come from? They've had a number of iterations over the years, the earliest being by Heroku back in 2011. Then there was a second iteration by both Pivotal and Heroku for their platform as a service offerings in around 2014. And the one we're talking about today is Cloud Native Buildpacks iteration, which was formed by Pivotal and Heroku in 2018. The concept of Buildpacks isn't specific to these companies. You can create your own. There's other examples. You can even use your own custom shell scripts as the binaries. Okay, so the core Buildpacks project is part of the Cloud Native Computing Foundation. So while it has contributors from a number of companies as well as individuals, it doesn't belong to any one company. This project is responsible for publishing two pieces of software. The first one is a CLI, which is called the Pack CLI. This is the CLI at your application directory to do the build. The next piece of software is the lifecycle binary. This orchestrates the running of the build, so it runs the detect and build binaries in phases that I mentioned before. The next thing that the project publishes is the spec or specification, which is like a contract that defines the interactions between an application, a Buildpack, and the platform that it's running on. Okay, so what we're talking about today is the Paketo Buildpacks project, which is part of the Cloud Foundry Foundation. And this is an implementation of the spec that I mentioned in the previous slide. So this also has contributors from a number of companies and individuals, and it publishes a range of build packs that support building applications in the languages you can see on the right. These include VM vendor build packs to supply the JRE, build system build packs like Maven and Gradle, and even a number of APM build packs that supply monitoring agents for the popular frameworks like AppDynamics, Datadog, and so on. Okay, so over to Anthony to show us the differences between building with build packs and a Dockerfile.
Yes, thank you, David. So now that we know that Paketo Buildpacks are definitely capable of building your container image, why should you migrate away from the Dockerfile, right? Because at the end of the day, Dockerfile has been there for more than 10 years now, and all the developers are kind of familiar to its format. For example, here we have an image definition that is based on the OpenJDK base image. There's no version there, so basically it's going to take latest. That's not a great thing, but oftentimes this is what we find. And then the user here, the developer, is saying that they want to copy something that looks like an executable jar, so apprunner.jar, inside the image. Then we set some metadata, work dir, and also the port that will be interesting to listen to. Then we have a combination of an entry point, java-jar, and a command that's going to, basically, when you're going to run this container image, it will just do java-jar and then the jar name, right? So this is what was expected. How would you do this using Buildpacks? Well, you would, for example, use the pack CLI, which is the default implementation. So you would use the pack CLI with the build verb, give the name of your container image, and then you would specify a builder. So here, this is a Jammy-based builder, but you could also set another one. And of course, you could have a default builder. So you wouldn't even need to specify the builder. Anyways, what does that do? It's not just simply java-jar that's going to be generated using Paketo Buildpacks. Why? It's because Paketo Buildpacks, they contribute many more things than just the app, the build app, and the JVM. For example, here we can see that the Paketo Buildpacks embed a memory calculator that is smart enough, for example, to distinguish whether you're using a reactive application or not. If it's a reactive app, maybe you don't need as many threads as a regular app, for example. You can also see that there is the mention of something that deals with CS certificate and that can actually add them to the trust store. We'll see that in the next slide. And also, like David, you mentioned earlier on, there is a Spring Boot build pack participating, and that could actually inject a library to help with automating the configuration for a data source, for example. Okay, are there any other advantages, you may ask? Yeah, let's go back to the custom CS certificate case. So for example, if you are in a development shop where you have your own custom authority, then probably you will want to actually propagate the public certificate of this authority. Okay, pretty standard stuff. So once again, with a Dockerfile, you would use kind of the same code as before, except that this time you will need to run the key tool during your build. So the key tool will probably import your public certificate, and then you'll be done with it, right? What would you do using the Paketo Buildpacks? You would have roughly the same command as before, except this time you would just provide a binding. So basically, there are Docker volumes. And then thanks to this binding, the Buildpack would know that, okay, we need to have a look inside this folder, CSS folder, and then from this folder, it will be looking for public certificates to add. There's no mention of key tool or whatever. It's just the CS certificate build pack that will know what to do in your case. Where that comes super handy is when basically you have to build projects in different languages. For example, here I have a Dockerfile for a Golang app. And as you can see, dealing with certificates in Golang or even Node.js is quite different from Java. So when your teams would actually write Docker files for all their applications to integrate the public certificate, they will need to actually maintain very different Docker files at the end of the day. But guess what? Using Buildpacks, they would always provide exactly the same command. Why? Because once again, we delegate the addition of a public certificate to the Paketo Buildpack named CS certificate, and it's the same, and it's the same Buildpack across all languages. It just understands how to do that in different languages. What about software bill of material, VSBOM? Well, guess what? Using Paketo Buildpacks, once again, you're covered. Each Buildpack will have the opportunity to contribute a part of VSBOM. And the great thing about the Buildpack contributing to VSBOM is that each Buildpack has access to the source code it builds with. That means that they won't need to actually code anything in the case, for example, of Golang or Rust, when you actually create a binary. Well, then they have access at the source code of those projects, so they are actually able to give you a precise indication of what are the versions of all the dependencies that are being used. So this is much richer compared to a solution where you would need to introspect a build container image, where probably the source code wouldn't be there, so you wouldn't have as much information. So this is quite an advantage of dealing with SBOM during the creation of your image. Also, the Pack CLI provides an SBOM command that allows you to retrieve this information also. Then one last point that we would like to mention as an advantage for the Buildpacks is that Paketo Buildpacks, like David, you mentioned earlier on, they also, well, the Paketo Buildpacks also includes some APM integration. So they are basically agents for providers such as Neuralink, Datadog, AppDynamics, and so on and so forth, and even the open source OpenTelemetry. So what does that mean? It means that easily, when you invoke a pack build, you can actually enable the inclusion of this agent. Sometimes just with an environment variable, such as with Datadog Buildpack, or sometimes using some configuration, the configuration that would be mandatory for this agent. Here in the Datadog example, to build and make sure that the agent will be there inside the image, we are just enabling this environment variable. And then at runtime, whether you're using Docker or you're using Kubernetes to run your container image, then you would just need to provide the additional configuration, once again, with environment variable or a specific piece of configuration. Pretty easy, man. Okay, we have some demo ready for you, and we're going to build an app directly created from the Spring initializer at start.spring.io. We're going to build it twice, one using the Pack CLI, and once using another Buildpack capable solution, which is the Spring Boot Maven and or Gradle plugin. Let's have a look. I hand it over to you, David.
Okay, so let's take a look at a sample Maven app here, and we'll run the pack build command. So all you need to do is give a name to your container image, give it a builder, which is the thing that contains the build packs, and then point it to your application directory. So the Pack CLI will run the detect and build binaries that I mentioned before in phases. You can see them running here. There's the Maven build pack that will do the build. Executable jar build pack sets the entry point or the start command, and then we can see the app container image being exported. Okay, app built successfully. So now we can run it with Docker run. Just give the app name. And you'll see the output that Anthony mentioned before. This is all the things that the build pack has set at runtime. And there's the app started. Okay, so that's the Pack CLI. Let's take a look at the same app built with the Spring Boot Maven plugin. So this is sorry, next slide.
Sorry.
Yeah, here we go. Okay, so this is the same app, and we've enabled the Spring Boot Maven plugin in the POM, and we can run the Spring Boot build image command. So this will build the jar within Maven, and then the plugin will hand the jar over to Buildpacks to run the detection and build phases again. So we can see the output that we've seen before. This time is just all within the Maven build. So we'll build our image, and we can do Docker run just to see it start up the same way. Okay, there we go. So let's go back to Anthony to talk through some of the advantages specific to Java that you get with Paketo Buildpacks.
Yes, thanks, David. That's right. The Paketo, the Java family of Paketo Buildpacks includes several individual buildpacks. And let's talk about what they can do for you. First of all, you can customize, of course, your Java version, and it's pretty easy to do. So you just specify the BP JVM version. For example, 24 was out just this month of March, and you can already use it. It's already provided to you. By default, the Paketo Buildpacks always include in a Java build the Buildsoft Liberica OpenJDK implementation. So this is their Jerry and JDK that we're using, but you can switch vendor pretty easily. You just need to mention your favorite vendor. So here, for example, you could use Microsoft OpenJDK, but we also include JVM from Amazon Corretto, Azul, Zulu, and so on and so forth. I already mentioned earlier on that we also include a memory calculator. So it's a binary that basically will understand your application and also your environment to better set your JVM arguments. So that's pretty convenient, because whenever your app starts, it will run and it will make sure that all the JVM arguments provided to you are going to take the best of your environment. Also, we have a bunch of Spring Boot optimizations that have been added recently to the Spring Boot build pack. So David, you already mentioned the Spring Cloud bindings. That is basically injecting a library that knows about the different third-party services that we need to configure your app with. But also there is, so this is one of the recent feature, class data sharing training run, the CDS training run. So after your application is built, we can actually do a training run with CDS. So that is going to be a limited run. And during this limited run, we will load all the classes and put them basically in a caching file. And then we'll make sure that this caching file is included at runtime. And of course, it's going to save you time and memory. Also, a very nice feature from the Spring Boot build pack is Spring Generation. It allows you to emit warning to the developer if they are using a deprecated version of Spring Boot. So basically, at build time, you will have some information about whether or not your Spring Boot version is supported. Okay, so let's see those in action. This time, we'll take an already built project, Spring Resbugs from Oliver Drodbaum. And this project is kind of interesting because this is a full-blown app that interacts with a database, actually. Okay, so here in this application code, you can see that it's built with Maven. And we have a profile that is named Buildpacks. And inside this profile, since we are using the Spring Boot Maven plugin, we can actually customize the behavior. As you can see here, we are taking a builder that is based on Ubuntu Noble. And also, we have specified a build pack that is from another vendor, which is Adoption. As well as the version, we said 24, and also we have enabled some Spring optimization, such as CDS and AOT. Thanks to that, during the build, that was, to be honest, pretty quick, the training run happened, and we generated this CDS caching file. So as you can see, the app is starting under less than a second, so it's pretty fast. And also at runtime, the build pack made sure to include the information, as you can see here, that allows the JVM to load those optimizations. Now, let's look at another profile that is included in this project, the Buildpacks native profile. And as you may guess, this one is going to be based on GraalVM. By default, we're going to use, the Paketo Buildpacks are going to use Liberica Native Image Kit, NIC, version 24. And also, as you can see, we have a BP native image environment variable that is being provided. Also, it's worth noticing that the NIC that we're downloading from Bearsoft is based on ARM64 because the laptop that was used during this demonstration is a MacBook M4 laptop, so based on ARM. And ARM is fully supported across the Java Buildpacks. Of course, native is super efficient, but it also requires you, the developer, to find out some hints. So here it was done for you by Oliver. But yeah, just to say that native is kind of impressive, but it takes a long time compiling. And also sometimes you need to find out those hints by yourself. So this is fast, but that's not also a silver bullet. I just wanted to mention that. When you start up, then yeah, you get even faster startup time with 200 milliseconds this time. Sorry. So now a question that you may wonder is, okay, Buildpacks are great. Okay, not sure what's happening here. Sorry about it. So Buildpacks are great. How do you integrate them to your existing pipeline? Well, for example, if you're already a Spring or Gradle shop, then it's kind of easy. You already got those plugins in place for you that were already demoed. Even from Quarkus, I think there's early support. If you are building using Kubernetes, then you could actually use Kpack. Kpack is basically a tool. So it's based on it's using custom resource definition where you would actually create a manifest. And in this manifest, you would give the URL of the source code to check out, as well as the builders and Buildpack to participate. And then Kpack would organize this, would understand this, and pull the different Buildpacks and builders to create your CI image. You can also rely on your favorite CI tool, such as GitHub Actions, GitHub CI/CD, and Jenkins. They all provide integrations with the Buildpacks, and they are official ones, actually. But if you want your platform as a service provider to build the image for you, well, you're in luck. Because Fly.io and Porter, for example, they both support the Dockerfile, but they also support the Buildpacks and even the Paketo Buildpacks implementation by default. So basically, you just give your source code to their tool, and then they're going to build it for you using their own builders. Heroku, of course, they are using their own implementation of Cloud Native Buildpacks, but you could also use the Paketo Buildpack if you prefer, since they are part of the same specification. They implement the same spec. Finally, we wanted to mention the cloud providers. Here, for example, with Google Cloud, there is the offering from the Cloud Run, from Cloud Run service, where it's kind of also it loads your source code and then going to build your application using their own implementation of the Buildpack. Once again, you could use the Paketo Buildpacks if you want to. And finally, Azure Container Apps, which replaces the now deprecated Azure Spring App and Azure Spring App Enterprise. So how does that work with Azure Container App? Same thing, once again, you just give your source code to Azure Container App, and then they're going to use Buildpacks, which are Paketo. Some of them are Paketo Buildpacks, and some of them are Azure maintained Buildpacks as well. So just wanted to say that when you're switching to Buildpacks, you won't be alone. There are a whole ecosystem of users and providers of Buildpacks. Now it's the end. Thank you very much for attending this session. You can take a picture of this QR code to have links to all the documents, all the documentation for Buildpack, and also the examples that we used. Thank you for being there with us, and enjoy the rest of the conference. Bye.
Thank you.